Lecture 7, Food Hazards from Purchase to Serving. The aim of this lecture is to provide an understanding of the hazards, controls and monitoring throughout food storage, preparation, thawing, cooking, cooling, reheating and serving. And the learning outcomes, by the end of this module, you should be able to identify how food is contaminated, when bacteria multiply and how they survive. State when toxins are formed and when spores germinate. Explain the various cooking processes. State the various temperatures required under law for cooking, reheating, chilling and freezing. This is quite a longish section, so if you want to get a coffee or a drink to keep you the side of you, but then again it's a video, you can always pause as you go through. So, good hygiene practices. It is assumed that the following prerequisite programs are all in place at all relevant stages. Now, prerequisite programs is part of HACCP terminology. These are the things really you should have in place before the main HACCP system kicks in. So, we start with satisfactory design and construction of premises and equipment, adequate facilities, the use of approved and reputable suppliers, effective cleaning and maintenance with maintenance contracts, good personal hygiene and training, staff controls, staff vigilance, effective supervision and competent staff, integrated pest management, contingency plans, satisfactory transportation and product information. So let's have a look at the hazards from delivery to service. So with delivery and unloading, we got the possibility of contamination and multiplication. Controls, make sure you use approved reputable suppliers. Make sure you give them specific delivery requirements. Chilled food must be delivered under 5 degrees Celsius, and you must make sure the food handler it is actually temperature probing the food to make sure it is that temperature. If it's above that temperature, then it must be returned. Frozen food must be delivered at -18 or lower, and again check with the food handler. If it's above that temperature, then reject it. Rapid unloading, so in less than 15 minutes. Food must be protected and covered. And there must be, if possible, depending on the size of your kitchen, a deboxing area. Delivery unloading, check the temperature and the time. Check the vehicles and the driver. Check packaging and date code. Make sure you use organoleptic checks. These are physical checks, so using your senses, sort of smell, taste, touch, etc., and your sight. And look at the condition of canned foods. Make sure there are no blown cans where they're bulging. Make sure there's no labels missing off the cans. And again, check all dates to make sure they're within date. Storage conditions required for raw meat and meat products. These must be held at -1 to +1 degrees C. Eggs, less than 20 degrees C. There is no requirement these days for eggs to be refrigerated. In fact, when you're using them in the kitchen, it's far better when they're at room temperature. Meat pies, for example, should be at less than 5 degrees C, so again, refrigerated. Pasties and sausage rolls, refrigerated, less than 5. Ice cream between -18 and -12. You will find when you're trying to serve ice cream at -18 or lower, it is like solid concrete. So bringing it up to -12 is okay. It's not going to hurt the food safety, and it will be easier to scoop. Milk, including imitation milk, less than 5 degrees C. Imitation milk, if it's sterilized milk or the UHT milk, that doesn't have to be refrigerated until it's opened. Flour and cereals kept dry in a dry goods store between 10 and 15 degrees C. Canned goods, again dry, same conditions as above. Fruit and vegetables, again same conditions as above, 10 to 15 degrees C, dry conditions. So ambient storage, where we keep dry goods, the hazards there could be contamination and multiplication. So the controls in ambient storage, make sure you've got good stock rotation, first in, first out. Make sure it's cool and dry, clean and tidy, off the floor, away from walls, held in rodent-proof containers. There's no chemicals in the dry goods store, no incompatible goods, for example, onions next to fresh fruit, care with handling, separate deboxing, and suitable shelving. Preferably not wood unless it's sealed by way of a gloss paint or varnish. The best shelving is probably metal shelving, stainless steel, aluminium, whether it's a solid sheet, which is easier to clean, but you can't get the, I think it's called the Wirax one, which looks like very thick wire, but they are difficult to keep clean. And how do we monitor? By audits and inspections, by looking at date codes, make sure nothing's out of date, the condition of the food, the condition of the packaging, the condition of the canned food. Defects of cans. What are the hazards there? Well, we could get contamination or multiplication. So defects include punctured cans, which can let bacteria in, for example. Dented cans, that could affect the inside seal of the can. A metal can, which is either aluminium or stainless steel, has a protective plastic coating on the inside. And if a can is dented, then this plastic coating can become fractured on the inside and release the food, or let the food come into contact then with the metal itself. Not so much a big problem with stainless steel, but certainly with aluminium it could be, especially if it's acidic food. A blown can is when there's a gas buildup in a can, so it could be due to, usually due to fermentation, with the release of carbon dioxide or hydrogen gas. That could tell you as well there's bacteria inside. And it could well be Clostridium botulinum, which prefers the vacuous container because it's an anaerobe that prefers vacuums rather than oxygen. Then you've got things called flat sour, rusty, flipper, which makes a noise like a flipper can if you press it, a springer, soft swell, hard swell, and a hydrogen swell. Again, further details of these you will find in the notes supplied with the course. So control of cans, again use an approved reputable supplier, care in handling, stock rotation. Monitoring, regular audits for storage conditions, visual checks of cans. Chilled food storage, again if done incorrectly, could lead to contamination and multiplication. So controls, make sure that the fridge runs between 1 and 4 degrees C. The legal maximum in the UK under the food safety regulations is 8 degrees Celsius. But that is quite a dangerous temperature as far as I'm concerned, because E. coli will start to grow. Studies have shown that E. coli will grow at temperatures of 4 degrees C and above. And when E. coli grows, it will release toxin. Separation of raw and high-risk foods. Stock rotation, reject unfit food. No overloading. Keep door closed. Care with hot food. Food covered. No open cans. Any cans must be poured into food safe containers. Food labelling. Door seals in good repair and clean. And effective defrosting, preferably automatic. Monitoring. Check the temperature regularly, at least 3 times during a shift, beginning, middle and end. And it's preferable to not just rely on the outside display, if there is one on the fridge, but to check the temperature of the inside of the fridge also, usually in product temperature. The best way to do this is to use a cup of dried salt. This can be kept indefinitely on the top shelf of the fridge. The salt is not going to go off. It might go damp after time. You might need to replace it. And what you'll do then, the 3 times that you check the temperature of the fridge, you insert your probe into the dried salt. In effect, it's like putting your probe into a piece of meat in the fridge, or a pie, or whatever happens to be there. But it's what we call non-destructive testing, because if you insert it in actual meat or sandwiches, then you have to dispose of that product. And regular audits and inspections. Check the condition of food. And obviously date codes need to be adhered to. I will go through codes later on, but the only 2 codes that's recognised by food safety legislation is best before and use by. Use by is a food safety date, and best before is a food quality date. Just a little bit more on codes as well, so it'll sort of sink in. Again, in the UK, if you use anything past its best before date, it is not illegal, but it doesn't show professionalism. If you use items past its use by date, that is illegal and you can get prosecuted. Frozen foods could give rise to contamination or multiplication. So controls include storing at -18 degrees C or lower. Use alarmed units, so if the temperature does increase, it sets off an alarm. Reject anything above -15 degrees C. Again, this is to do with deliveries more than anything. Don't fill above the load line that it tells you in the freezer. Get effective stock rotation. Again, it's far better to use upright freezers than chest freezers, because chest freezers are easier to keep stock rotation going in some order. With chest freezers, everything sort of ends up at the bottom of the freezer. Handle carefully, use suitable packaging, label with date and description, separate raw and high-risk foods. Monitoring, check temperature regularly using audits and inspections, check the condition of the food, and check the date codes. Again, food will last longer in the freezer than the fridge. You'll normally find the recommendations on how long you should keep food in a freezer on the packaging that comes from the supplier. But if you're using fresh meat that's been cooked yourself, or raw meat that you got from the butcher and you're freezing it, it's best not to keep it in there longer than 3 months. After that time, it will tend to go rancid. You will get oxygen entering the fat and giving it an off taste. Although you can keep it in there for as long as you like from a food safety point of view, but from a food quality point of view, the taste is highly affected. Hazards with frozen poultry, for example, contamination and multiplication. Controls: always separate from high-risk foods. Refrigerate when thawed. Cook thoroughly within 24 hours. Clean and disinfect the work area. Eat immediately or cool rapidly. Avoid handling whenever possible. And thaw completely. In a room at 10 degrees C, you can leave it there overnight. If it's less than 15 degrees C, you can, for example, cold water. You need to make sure it's held in cold water overnight. You've got fridges you can use, microwaves, thawing cabinet. There are many ways to defrost. Probably the quickest, safest way is a microwave, because it so quick, and then you can cook it. You can defrost a whole frozen chicken within about 30 minutes. If you use a thawing cabinet, it's held at a temperature which means that it'll take overnight to actually defrost. A fridge actually takes forever for poultry to defrost, although that is the recommended way to defrost poultry, in a bottom fridge in a covered container. Cold water is quite good, but not using running water, because you'll get splashes of Campylobacter come from the chicken, and some of the water will be aerosolized, and that could end up on walls and surfaces, etc. Stock rotation. So make sure that food is thoroughly coded. You can get color coding is a good way of stock rotation, like day dots. Use by dates, always make sure you abide by those. They are food safety dates. And these you'll find on perishable foods. It's considered unfit after the date. It's an offence to contravene, as I mentioned. It's an offence to change the date. And there's been recent undercover operations with certain poultry producers where somebody has videotaped people actually changing the dates on poultry and the poultry being sent out to supermarkets for sale. Best before, this is a food quality date. It's no offence to sell after date if it's fit. The manufacturer guarantees the quality to this date. The shelf life depends on satisfactory storage conditions. So, first in, first out, FIFO, that's what that stands for. So if you've got new stock coming in, that goes to the back and the old stock comes forward. So it ensures older food is used first. It avoids spoilage, mould, slime, unfit food. It avoids wastage. It guarantees constant quality. It maintains correct stock levels, and it reduces the risk of pest infestation. Label accurately. Make sure all the storage information is on the label. Make sure you do daily and weekly checks. Written stock control records. Hazards from food preparation include contamination and multiplication. So the controls: separation of high risk from raw foods, ensure colour coding, disposable cloths, organisation and workflow, minimise time at ambient temperature, minimise quantities prepared. And monitoring would include audits and inspections as usual, time at ambient temperature, and the temperature of food. So cooking and processing, we can get contamination, multiplication and survival. So controls here will include: make sure you cook food to 75 degrees C from a food safety point of view and from a Food Standards Agency and other agencies' concerns. But as I keep on banging on, from a food quality point of view, anything between 60 and 63 is fine. Stir liquids regularly so you don't get a build-up of cool spots, cool areas where any spores could actually germinate. Care with mince and rolled joints. Ensure everything's completely thawed before cooking, unless it's a small item. Cook near to eating, because the number one cause of food poisoning, which I mentioned earlier in the lectures, is producing food well before you need it and keeping it at ambient temperature, not keeping it hot. You need to protect from contamination and care with acid food. Cooking and processing monitoring: check the times and the temperature. Use a disinfected probe thermometer. Audits and inspections. So cooling, you can get contamination, multiplication and spore germination from inadequate cooling. Controls here: cool rapidly where possible, minimize the size of the joint, make sure the maximum surface area and temperature differential is high. In other words, don't put a large pot of food stuff, whether it's a stew, casserole, gravy, etc., into a fridge. Tip it into shallow containers so there's the maximum surface area and it will cool down more quickly. We got different standards of cooling. The American standard and the Camden standard, and you will find these in the notes that are supplied with the course. It depends on the various temperatures that are accepted by the different standards. You need to refrigerate when cool, i.e. at ambient temperature, and cover and protect food. Monitoring: check times and temperatures, audits and inspections. Reheating, we could get contamination, multiplication, or survival. So with the controls, we need to reheat to 75 degrees C. Strangely enough, it's 82 degrees C in Scotland. No idea why that is, and nobody can give me answers to it either, because 75 degrees C is high enough. Boil liquids when you're reheating. Regen or regenerative ovens are recommended because they use a high temperature over a short period of time. Commercial microwaves are satisfactory. Try to minimize the bulk, so small portions. Only reheat once, and protect from contamination. Monitoring, check temperatures and times. Audits and inspections, our old friend there. Hot holding, we can get contamination and multiplication. So the controls, it must be held, or the food must be held above 63 degrees C. That is a legal temperature. There must be thorough cooking prior to holding it at that temperature. You need to preheat equipment, use minimum quantities, and protect from contamination. Monitoring, check temperatures and times, and, you guessed it, audits and inspections. Serving food, contamination and multiplication. So we control that by serving quickly. So producing food and serving it as quickly to service as it has been produced, rather than keeping it hanging about. Minimize time at ambient temperature. Use good stock rotation. Small quantities. Minimize handling. Use separate staff for different processes. And avoid customer handling. And protect from contamination. Monitoring again, check temperatures and times, and audits and inspections. Also date codes and looking at the condition of food. So again, using our organoleptic sensors. Cook chill. This is where food is cooked specifically to use as a cold product. So it's cooked, it's chilled, refrigerated, then kept cold. And hazards here include contamination, multiplication, and survival. 9 stages of cook chill. We have bulk storage, preparation, cooking, portioning, blast chilling, storage, distribution, regeneration, and serving. And at each of those stages, there must be full protection of the food from outside contamination, and storage areas, depending on the food, either refrigerated, ambient, or frozen. Preparation must be done as quickly as possible and use small quantities at a time. Cooking thoroughly to 75 degrees C. Portioning, again, must be done quickly. Blast chillers are like fridges, if you've not encountered these, but they do continually blast very cold air over the product. And you can actually take food out of an oven straight into a blast chiller, and they'll take it down between 1 and 4 degrees C within 90 minutes. They're that efficient. Then after blast chilling, storage, either refrigerated, frozen, or chilled. Then distribution, using clean food safety transport. Then the food then is regenerated. I did say storage at frozen. This is cook chill, so there won't be any freezers involved. It'll just be storage in fridges. Regeneration then to above 75 degrees C, and serving as quickly as possible. Safety rules with cook chill: use good quality materials. Make sure the specification is enforced at each point. Raw products should be stored correctly. Avoid cross-contamination at all times. There must be physical separation. Separate equipment, separate staff, controlled thawing. By separate is separating equipment staff from raw and from cooked. In other words, you'll keep the staff separate. You'll have staff preparing the raw food. You'll have staff preparing the cooked food. after it's been cooked, they will be using their own separate equipment as well, such as knives, preparation boards, slicing machines, etc. There should be controlled thawing, high hygiene standards, good personal hygiene, staff suitably trained, commensurate with their work activities, but in my view, every member of staff as a food handler should be trained to at least level 2. Temperature control, round about 3 degrees C. Anything between 1 and 3 really, as long as in certain fridges, if we keep vegetables or fruit or salads, it could freeze. But then again, with cooked chill, it normally doesn't affect salad items. We are looking at cooked food. The safety rules with cooked chill: there must be a HACCP system in place. There must be date marking in use. Hygienic food containers must be used, food safe containers. Life is 5 days from preparation to consumer. If over 5 degrees C, consume within 12 hours. Over 10 degrees C, destroy. Regenerate quickly after storage. Benefits of cooked chill: it's more cost effective because there's less wastage, lower staff turnover, fewer staff due to centralisation of the satellite kitchens. Energy consumption is reduced because regeneration is usually done in one place. Less floor space. Benefits of bulk purchase. Better equipment utilisation. Cook freeze. Hazards there could be contamination, multiplication and survival. So the steps involved in cook freeze include bulk storage in freezers, preparation in as quickly time as possible, cooking, portioning, blast freezing, taken to minus 5 degrees C in less than 2 hours from leaving the cooker, and subsequently to minus 18 degrees C or lower. Packaging and labelling, storage for up to 12 months, and regeneration, 75 degrees C or 70 degrees C for 2 minutes. Although I would ignore that second bit. This must be an old slide. You haven't got time to mess about holding a probe in place for 2 minutes. If you take it to 75 degrees C, that's an instant temperature. Sous vide literally means in French under vacuum. And I've been experimenting recently at home with a sous vide stick. What it means is you wrap foods in pouches, then you extract the air from the pouches with a vacuum sealing machine, and these vacuum packs then are held in a water bath at a specific temperature for a specific period of time. It's a method used quite often in upper class restaurants, especially in Michelin star restaurants, where they cook in things like steaks, duck portions, lamb steaks, etc. And they cook it at a temperature of between 60 and 63, although some have experimented between 56 and 60 degrees C. Again, these temperatures are safe because all food safety bacteria are killed at those temperatures, and the food is cooked for longer than normal, as would be in an oven. They're held in a water bath for between 1 and 2 hours. After the food is cooked, the steak or the meat item will look very pale and appetizing. So the chef will do then. They might well finish it off with a blowtorch to actually give it colour, or they'll pan fry it on either side for literally seconds to give it a bit of colour, because all the cooking is being done and all the juices and succulents are still inside the meat, because none of the proteins are really coagulated that much to squeeze all the juices out of the meat, which you will get from overcooking, and especially at 75 degrees C. So the process is storage and preparation, vacuum packing, heat treated by controlled cooking in moist heat, and held at low temperature over a long time, blast chilled, stored at less than 3 degrees C, and reheated for service. With sous vide, food is not commercially sterile. So anaerobic conditions do exist after cooking. That's why these pouches, if they're not used straight away, as I mentioned in a restaurant, they're kept under refrigeration. They must be kept under refrigeration because if they're kept at room temperature, even with the vacuous conditions in the pack, things like Clostridia and Bacillus, especially Clostridia, they will multiply in those vacuum conditions, and that can cause problems. The safety relies with sous vide on rapid cooling, maintaining a cold chain, and the integrity of the pouch. Advantages: there's an extended shelf life, less shrinkage, enhanced sensory quality, improved nutritional value. So, the key points of that section. We looked at the major hazards: contamination, multiplication, survival, toxins and spores. Good stock rotation is essential. It's illegal to sell or use food after its use-by date. We looked at canned defects. And again, a lot of these defects you can find in the supplied notes. Chill storage of food should be between 1 and 4 degrees C, preferably less than 3 degrees C. The legal maximum is 8 degrees C. We looked at thawing of raw meat and poultry. We looked at how vacuum packs require refrigeration because anaerobic bacteria can still survive in a vacuum. Cook food and reheat to 75 degrees C, weirdly 82 degrees C in Scotland, and store at 63 degrees C or above if you're keeping it hot for service. Cool hot food rapidly, then refrigerate it. If you cool it rapidly, it's preferable to use blast chillers if possible. And temperature control after process is critical. And the cook, chill, cook, freeze, sous vide, cook, chill processes we looked at, and there were various benefits put forward for those processes.